Okay, let us also see this example, how you go about it. Now this one is about propagation of errors in the quotient or divisions, in quotients or division. So that's how we see it. And now these were the exact values which were approximated to a small a over root b. So we want us to reduce or show that the relative error is given by this entry and reduce the maximum relative error. So what we do, because we are seeing, normally say that we are seeing a rational function here, root b, irrational, that one root b, always, then we always start by removing this square, or it can be a cube root, it can be a fourth root. So what we do, if we have a square root, we square both sides, and when we square this, we get z squared, when we square this, we get a squared, when we square root b, we get just a b. So from there, if we get this one, we start z is the value with the a and b. So a small change in z leads to a small change in a, and also a small change in b. So imply that if I have z and I get a small error in z, it means that also I'm going to get a small error in a. But I told us that a is having e1 as its error. It's squared, then over b will be also having a small error in b, which is 2e2. As simple as that. Now, what happens here? You see that now, what we are going to do here, we can expand this, and also after that we get, I want to create the difference of the squares, because this one, I want to create the difference of the squares. So what I'm going to do, I multiply by b minus e2, both up and also down. So, this is the same as a plus e1 is squared into now b minus e2 over, then here the same thing, b minus e2. You see that one as if it's going over. So it's like I'm doing nothing, because this will pass and I go back to this. So after we expand that, so this will now be, when we expand this, we get a squared, then plus 2a e1, then plus e squared 1 into now b minus e2, the whole here, and then here is the difference of the squares, which is b squared minus e2, 2. That's the difference of the squares. Now what happens here? I'm going to factorize out this b squared. So if I'm factor out that b squared, I'll be having now a squared plus 2ae1 into b minus e2 all over. Remove b squared. If I remove b squared, what you remove you divide. So if you divide here by b squared, you get 1. If you divide here by b squared, you get b squared 2 over b squared. So now that now, the whole of this is equal to this. So can we expand this? This is z plus, okay. So now if you try to expand that thing up there, and make space with it now for us. Okay, let us try to do that there. So if I try now, this was z plus e z squared. So let us expand now this. We shall be having z squared plus 2z is z, then plus e squared z equaling to the whole of this. Now look at our e squared z will approximate to 0, comma, what else? E squared 2 over b will approximate to 0. Something is multiplied by something big even you square it will also approximate to 0. So here I'll be given now z squared plus 2z e2 equaling now to, now you also see that our e squared 1 will also approximate to 0. So here I have a squared plus 2a e1, because this one is going to be 0, then b minus e2, the whole over now. This will be 0, so this divided by 0 to be 0, then minus 1, it will be 1, and this will get b squared. So what happens there? We are going to expand, and I take this z squared the other side. So this side will be having 2z E2 equaling 2. When we expand here, we get a squared b. Then this times this plus a squared E2. Is it minus? Yeah, I think it's minus. Minus. Then this time this will get plus 2ab a1. Then minus 2a a1 a2. Then minus then squared. Remember, the whole of this from here we are dividing with b squared. Okay, so from here, now start this one, not that. E1, E2 will also approximate to 0. So here, shall be having now 2z E2 equaling 2. Now here, I'll be remaining with a squared b minus a squared E2, then plus 2a b E1 the whole over b squared. But remember, I'm subtracting off z. So z squared. So then minus z squared. Minus z squared there is a squared over b. This one here. This z squared here. I'm subtracting off this. So minus z squared from there. Substitute that. So here now we get LCM. If you get LCM. Okay, so this will be z to E2 equaling to the LCM. This one will remain a squared b minus this one is the LCM is this. So this goes here b times that we get a squared b. Now the whole over b squared, the LCM. So it's that now this will vanish with that. So remaining with it now something is positive. So what we are remaining with is 2a b e1, this one, then minus a squared e2, the whole over b squared. So let us divide through by this 2z. So my e in z, this is error in z, error in z. Let us not get this is error in z. Error in z, error in z, this is error in z, error in z, error in z, error in z. Our error in z is going to be now, when you get this, we have 2ab e1 divided by b squared. But remember, we are dividing also, divided by this 2z, then plus a minus a squared e2 over b squared 2z. After dividing by 2z this side, also 2z. So 2z b squared divides this, also divides that. Remember, if you get this and this, we shall go back to this negative. Okay, so what happens? So this 2 is vanishing with this is vanishing with that 1. Then what happens after there is that here now we have our Ez equaling 2. Okay, let me write it here. Our Ez is equaling to a over b, a1 over z, then plus a minus a squared e2 over b squared to z. Now, if I want now the relative error, I get the error in z. So relative error, let me do that. The relative error, if I'm finding my relative error, it will be now Ez over z. So now this will be the whole of this I divide with a e1 over b z. Now I divide by z. I'm dividing with this z. Then plus a negative e divided by z. And we say 1 over z divided by z becomes 1 over z squared. So you can note that this is going to be a1 over bz squared plus or minus, not plus or minus. Then this will be 2z squared b squared. So I think we know what our z squared is. From there, I think you see if I can put it here, I'm going to be having A E1 over B. Now I'm putting this A squared over B, then plus minus A squared E2 the whole over 2 into Z squared, which is A squared over B times B squared. So what we get there is that this B is going to go with that, 1A is going to go with that. Then here, this A squared will go with that, then 1 will go with that. So that this will be now equal to A1 over A, then plus negative A2 over 2, what is remaining is B. B is remaining there. So that is our relative error. That is the part A. My relative error is given by that. If you get the absolute value, the relative error, you can remember saying we can get the absolute value of the error of this thing. So if you get the absolute value of the relative error, so you see our relative error will be equal to the absolute value of this and then the absolute value of that. So now from here they are saying introduce the maximum relative error. So the maximum relative error, so you get the modulus this sign also shall be getting E, E1 of A. Okay, before we introduce that to the whole, then plus this will be negative E2 over 2B. So now, if we handle this, remember we say this will be the same as equaling 2 all this 2 if we separate E1 over A, then plus negative E2 over 2B. So if you have hand up there now, you start now my relative error, the maximum. If you want now to go with the maximum, it means that we shall take when it's equal to this. So my relative error max is going to be when now it's equal to this E1 over A, then plus modulus of this will be equal to a positive of that over B. And remember, we'll take that half out. That's what we get there. And so that will come the maximum relative error. Now, from here, in getting the relative error here, you can come here and take the modulus straight away. You can take the modulus straight away here to get the absolute value of this and this. Then you can come and then improve this to be our relative error. Then the maximum is when you take this equal to that. That's when you can get the maximum. That will be added there. So see you there.